and welcome to today's LPA webinar on machine learning with Watson Studio and DSX Local. My name is David Russell. I'm the Chief Technology Officer at LPA, and we're going to be talking today about IBM's products around machine learning and predictive analytics that are based upon popular open source tools like Spark, R, Scala, Python, and others that deliver a unified environment for all of your data science needs. If you're not familiar with LPA, LPA covers the breadth of IBM's analytics products. We're a platinum business partner, and we can help you in any phase of the analytics lifecycle. We can help you to build up your governed and trusted data sets through our information management practice. We can help you with planning around IBM Planning Analytics. We can help you with descriptive analytics. We have one of the leading IBM Cognos Analytics consulting practices. We can also help you with your diagnostics, whether you're looking to use Watson Explorer to investigate unstructured data or wanting to incorporate Watson Analytics into your tools for smarter data discovery. We have a practice in predictive analytics where we cover IBM SPSS products, including modeler and statistics. And we also can help you with Data Science Experience and the tools that we're going to be looking at today around machine learning as you journey towards artificial intelligence in your own business. And finally, we also have capabilities around prescriptive analytics to help you to optimize the decisions that you make based on those predictions that you create in your business. So today we're going to be talking about data scientists and the problems they may be having and how we can use some of the tools that IBM has created to improve their lives, to improve their capabilities within your business, and to speed their delivery of the findings that they have and the insights they gain through their analysis of your data in a way that can be consumed throughout the organization. So, some of the challenges that your data scientists have today is, they're working with something of a rigid tool set. Frequently you have your data scientist chooses a tool that they prefer to use, and when they get into your organization, they may find that you have only one tool available to them because we like to standardize and we like to make IT simpler, and that can create a problem when you're bringing in new data scientists who maybe don't use the same tool that your organization does, and they may have great ideas on how to analyze the data, but they may feel like you're essentially putting them in handcuffs by not allowing them to use the tools they want to do. Now, the fact that they frequently use different tools depending on what their background is and what they've learned to use, sometimes that can create a fragmented environment, where each of the different data scientists uses a different tool they've installed on their desktop and they've got things running there, and how they move that into a production environment and how they move that into a world where you can use their insights across the enterprise can be difficult and time consuming. It can create problems for how you manage the data that they're working with. If each person's working on their own desktop environment using the R or R Studio that they've installed locally, they pull the data down locally to their desktop, they start using it in that local environment. And as they work with that data and potentially massage it to try to improve the data set, how do they share that with other people within their organization that need to see that data set they're working with, and other data scientists that they need to collaborate with? And that collaboration problem, generates these analytic silos. It can be difficult to maintain, versions of the data or versions of the source code that you're working with if you're working in R or Python. It can be sometimes difficult to share those intermediate results. We need to find ways to help those data scientists deal with those challenges and deal with those problems so they can be more effective in their business. We also have those difficulties that I already mentioned about how do you deploy those machine learning models. You have your data scientist wants to be able to share what they've learned and the insights they've gained in a way that other people can take advantage of, and they want to have some standard way to manage the models that they've developed and the predictions that they can create in a production environment. They need to be able to keep those up to date, and they need to make sure that when they gain new insights, that those can be delivered out into the enterprise as easily as possible. Our application developers, then they need to consume what the data scientist generates. You have your websites and you have your internal applications that really would benefit from these insights, because if you just have your data scientists exploring your data and analyzing things and trying to come up with new insights on their own, and they're not able to deliver those to the end customers and the end users, it's been a waste of time. So those application developers need to be able to incorporate that. They want to make sure that they know when the model is valid. Do they have a life cycle to these models? Because they keep being told by the data scientists that it needs to be updated frequently as new data comes in and new knowledge is gained. So in that environment, we really need to find some way to allow that. And the way IBM is suggesting you access these, particularly in a real-time integration sense, is through these RESTful web services, giving your application developer a way to call into the models that have been developed by the data scientists through a standard set of web services that meet the standards the application developers expect today. And then the data scientists then can be working on the implementation behind the scenes of that web service to keep that actual model up to date in a way that the application developer doesn't have to worry about it. So this leads us to a component within a number of different tools that IBM provides called Watson Machine Learning. The idea is that you take the data that you have internally, that's governed and controlled through some platform, and you can pull that data that you have, whether it's in a public cloud or behind your firewall within your organization or a private cloud that you have somewhere, and pull that in a way that you can analyze that data and you can build machine learning models and these predictive models in a way that you can then expose them through this web service. And this web service can provide either real-time analysis, so that I can send a single record to my web service and have it score that record and give me a prediction or a classification for that record. It could do batch processing, where I can call a web service with either a batch of particular items to be analyzed, or perhaps I can call it and tell it to analyze data in a database on the back end. But that batch analysis can be done through the web service. And the Watson Machine Learning also provides the tools to provide you monitoring of the web service and provide you a feedback loop for understanding when your model is degrading over time and understanding when you need to update or retrain that model, or even put your model into a continuous retraining where it automatically retrains against the latest data on some regular basis. This allows your application developers to integrate that machine learning directly into your end product, whether that end product be an internal application or a customer-facing application on any of a number of different devices that are available out there, and allows you to use those web services as the entry point to continuously provide new insights based on the data that you have inside your organization and new predictive models that you have. The other thing that IBM is committed to is the idea of allowing you to do this machine learning and to deliver this machine learning through whatever platform you're seeking to implement within your organization. We are committed as an organization as a IBM business partner and IBM itself to the idea of the fact that you're in a multi-cloud environment and you're in the transition from an on-premise to pure cloud, and that you have public cloud capabilities that you need and private cloud capabilities that you may need, as well as crossing multi-cloud, whether that multi-cloud be between a public and private cloud or whether that be across different vendors' clouds that are available to you. And IBM's commitment there has allowed them to release a number of different products to support you wherever you may need to do machine learning. Everything from in the IBM cloud with the IBM Watson Studio and the public cloud component there and the machine learning capabilities delivered there, to the IBM Data Science Experience Local that allows you to deploy many of the same tools available through that Watson Studio in the cloud to your own private cloud environment. That could be IBM's cloud private product that allows Data Science Experience to be deployed on top of that platform for delivering your own cloud, whether that is installing Data Science Experience into cloud provided environments from other vendors, or potentially on-premise with your own infrastructure and own capabilities that you're maintaining either as an internal private cloud or even bare metal servers. Data Science Experience Local is also delivered as a component within the IBM Integrated Analytics appliance. This is the new massively parallel processing application data warehouse appliance. I said application, I mean appliance, that IBM has that delivers the, if you've heard of Netezza, the database capabilities and DB2 warehouse and DB2 Blue capabilities on a data warehouse appliance, that also has the Data Science Experience and the machine learning capabilities built directly into that platform. So let's look at what I'm really talking about. What do I mean by machine learning with IBM and the tools that are provided? So we're going to start in IBM Watson Studio. We're not going to go through the whole Watson Studio interface and all the different capabilities here because there are many. We're going to focus primarily on the machine learning capabilities. But to give you a high-level overview of what Watson Studio provides, it provides an interface and an integrated environment for working with data sets in a project-centric environment where you can have Jupyter notebooks stored within your projects and other assets. So if we go and look at a particular project, we can see that we have a number of assets and collaborators and different environments that are set up. So if we look at the different assets in this, we have a number of different connections to databases. We have text files that represent data that we may be interested in and data sets that we're working on. We can have notebooks in a variety of different languages that different collaborators can be working on. We can even have, these are predictive models that we've built, and this is where we're going to focus our time on how do you build these predictive models and what does it mean to build a predictive model. You can even have graphical flows similar to IBM SPSS Modeler that allows you to analyze data in a visual tool. And those flows can be stored in this collaborative environment and used and shared by the different collaborators within this project. So for today, we're going to look specifically at what it means to do machine learning and use the model building capabilities of machine learning and the machine learning tools. So we're going to start with the idea of wanting to build a model. In this case, we're going to use a sample data set to predict what someone may buy based on their past history of purchases. So we're going to start with adding a new data set to our project that we're working on. This data set that we're going to work with could be anything that we might have found, either in this case a CSV file that we've potentially retrieved from another system that we've, or this could be a CSV file that we've exported from a notebook where we've done further refinement and analysis of the data, or have done some sort of data preparation to create the types of predictors that we want for our model. And once we have this CSV file available to us, we can then create a new model using the model builder capability. So in this case, I'm going to look at product prediction, will be my name of my model. In this case, we're going to use the model builder, and we're going to just use a Spark executor that's already been created. Since this is a public cloud environment, we can choose to create different Spark services, and these are usually pay-as-you-go in this case. In this case, we're going to go really simple. We're going to go with an automatic model build, and we need to make sure that we analyze or add a machine learning instance. So again, the machine learning in the cloud in this case, is a service that we can integrate. There's a free service that allows us to use up to 5 model instances. And so I'm going to create a new service, and it's under there, and that's going to be the name of it. We will add a reference to this new service that's being created to our existing project so that other people working with this project can access this machine learning service. And now that I have this machine learning service and I have a Spark executor involved, I'm going to allow the model to prepare the data itself to do any transformations, further transformations of the data in order to provide a prediction. One of the things we'll note when we get around to selecting our data is that this data set is relatively narrow in that it has a few predictors and one field that we're going to use as our label for training. So once we've picked the data set that we're going to work with, in this case, this Go Sales demo data, and it's going to then give us the opportunity to choose what our label column is. So in this case, we want to know, is the person likely to buy a tent? So this is based on past history of tent purchases and the information that we have about the gender, age, marital status, and profession of the person involved. And based on those inputs, we're going to try to predict whether they're likely to purchase a tent. So is tent is going to be a binary classification. It's just true or false. Did they buy it or not? So we're going to stick with the suggested technique of this binary classification. We have the opportunity to separate the data out. So this is always best practice when you're building a predictive model, and this allows us to choose how we want to do this split. The idea is we're going to keep 60% of the data is going to randomly be sampled out to be used as our training data set. We're going to use 20% of the remaining data is going to be used to test that. And then 20% of the data will be held out off to the side, won't be used in testing or training of the model. So since we told it to use the automated data preparation steps, and we've told it what we want to do, the next step is it's going to attempt to train a model based on the data that we have and the data split that we've given. And this can take a few minutes for the model to actually go through the training process, and it varies based on the volume of data that you have available for training. In this case, we have several thousand rows, so it's going to take a little bit of time for the model to work. In this case, it's chosen to use logistic regression because we have a binary output, and the inputs, it's decided to transform the data into a format that can be used for a logistic regression. And once it's done training, it gives you an idea of your ROC curve numbers and your PR curve numbers. It also gives you a text evaluation of the performance. It says this is a fair model, so it's not great, but it's not a poor model, so it's something that we may be interested in trying to use. You could delete this training and start over and allow it to retrain the model if you wanted to do something with tweaking your ranges, or maybe you'd want to go all the way back and choose to do manual data preparation instead of automated data preparation. But at this point, we've got a model that we believe it's fair. We're going to save the model. It's going to make sure that we really want to save this model. So what it's doing now is it's saving the model where we've taken our input data, we've trained the model, and I always think of it as weights. Not every model is really storing weights, but it is a logistic regression model, so that's really what we are doing, is we're storing the weights and we're taking those values and we're putting them somewhere where now we have a model that we can use for scoring other data that we have. So we have the opportunity in this environment to do additional evaluations so that we can configure performance modeling, and we can set up a long-term connection where it will, if we have a DB2 warehouse connection, we can have it store data about the predictions that we have and the actual values that that we get back from those predictions. We can evaluate the performance long-term for this model. We're not going to do that today. We're just going to skip forward to the next step, which is the idea of a deployment. We're going to add a deployment for this. In this case, we're going to create a web service that's going to provide our deployment, and we're going to say, will they buy a tent, will be our name that we'll use. And we're going to deploy that to a web service. So now that we've done that, it's going to take a minute to go through and initialize the web service and get it up and running. It's done deploying it. So now we have that model that we've built available to us as a web service, and we can do a few things here. So we can look at the underlying implementation. We can see how this has some samples of how you might call this web service, so that if you're working with your different developers that may be using different languages, whether they're using Java or JavaScript or Python in their application development, this gives them and demonstrates to them how they would go about making calls to this web service to retrieve the scores. And we have the full specification for the API that we can go look at as well if your developers want to see what those specifications are. We can also test this right here in this environment. So we can say, okay, this is someone male, they are 23, they are single, and let's say they are a laborer. And we're going to predict whether they'll buy a tent. In this case, not very likely. And let's say so again, not very likely. So let's see about a 23-year-old female who's in the hospitality industry. Now, they have a much greater likelihood. They still aren't. Let's see what happens if we have a male in the hospitality interest. They're pretty equivalent in that case. So the point is, we have this model that's available to us, and it runs. The other thing we can do is we can demonstrate to ourselves Data Science Experience Local. As you can see, the interface is rather similar to what you see in IBM Watson Studio, but this version is running on a private cloud. So I have VMs that have been provisioned in a different cloud, and I have deployed the components of the Data Science Experience Local to those cloud VMs. And so now I have an environment that's within my own controlled set of machines and I can do a lot of the same things that I've done before in Watson Studio. So here I have projects that are very similar to those, if not the same, as those that you see in Watson Studio. So I have created my own machine learning demonstration project here. And again, I have my assets and my different environments that I can run things in. My assets may be notebooks, or maybe models, or data sets. So in this case, we can look real quick at a notebook. One of the things that's interesting is the same IBM machine learning deployment environment in the cloud that you have can be used to deploy models that you create in a notebook. So this notebook has an example of creating a Python Spark model using the random forest classifier in this case, and training the model. And then at the end here is we're actually taking this and storing that model into the Watson Machine Learning repository. And then we are taking that repository and we are actually creating a new deployment from that and using that deployment, that's down here, to create a new REST API just like we did before, and allows us to create a real-time scoring API from a Python model that I built here in Spark in a notebook. And it only takes a few lines of code to actually do that and have a similar type of model deployment process here. In this case, though, just wanted to show you using the machine learning, the model building tool again. In this case, we're going to add a new model, and we're going to classify, this is processes. So the data set that we're going to be using in this case is a data set for processes being run on high performance computing architecture, and we have information about scheduling of those jobs and how long they take to run given the time of day and the complexity of the run. And the goal is to build a model that's going to predict what class of execution that particular job is going to be. Is it going to be a longer executing job or a shorter executing job, in order to more efficiently schedule the jobs on the high performance computing system. So that I've loaded up the system, label, which is class, and it's interesting, we get a suggested technique of binary classification. We really have a multi-class classification in this case, so I'm going to go ahead and tell it that we want to do a multi-class classification. Just like before, we're going to split our data set out as per best practices into a training set, a testing set, and a holdout set. So now we'll train the model and we'll see what we get. So in this case, the text is telling us it's a poor model. It's only about 58% accurate, if you will, 60% accurate. But that might be good enough in this case. We want to be able to do a little better job of scheduling, and maybe that slight increase over that not having a model is enough for us to get by. So we'll save the model just to see what we have here, and just like before, we'll end up with a model that we have available to us to be used for local batch processing. There is an additional capability with DSX Local that you can add on a model deployment, and we don't have that configured today, and we won't be looking at that today, but it allows you to do a lot of the same types of deployment and creation of web services, very similar to what you do in Watson Studio, but it has more advanced capabilities for monitoring and retraining in this environment that you have more control over than you do in the Watson Studio product. So now that we have this classify processes model that's been put out here, we can go and we can look at, similar to before, we can use it to test what we have. So we have a few inputs that are our features coming in, and we have our outputs there. So in this case, we can go to test, and it has some sample values here that it's providing as our test. We can hit submit, and it will give us the prediction that we have around, we have our 4 classes, and we see that this is most likely to be in this VF class versus these other 3 classes that are available to us. So very fast, I believe, versus large, medium, or fast in our different classification schemes. So we can change some of these values and try to, see if we're going to do 2,000 iterations, and we submit that. It changes the prediction. It says, no matter what, this is a large job, and it's going to take a long running process to do that. So we have that ability. We also have the ability to create scripts to both batch score other data sets. This builds a job. It builds a Python script that you can schedule and have run at certain basis to batch score against this model that we've created. You can also evaluate the model just to validate that it continues to be up to speed. And this is the simple evaluation. You get more advanced with the more complete tool set. So that should give you an idea of what our capabilities are, both in Data Science Experience Local, very similar to what we've seen in the prior demonstration, and give us a good starting point for where you could go with machine learning in your environment. So how can LPA help you? We'd love to help you no matter where you are in your analytics journey. When it comes to predictive analytics, machine learning, those tools, we'd love to help you with training and enablement services, as well as predictive analytics services, where we can simply come in and help you to develop a model given whatever tools you've decided to use in your organization. We also have the ability to help with an analytics roadmap, where we can help you understand where you are on your analytics journey and where you want to be, and the path that you can take to achieve your goals. We didn't have time for questions today. If you did post any questions, we will try to get back to those as soon as we can. Thank you for your time. Have a great day.